Hi everyone. Now we are going to discuss the fundamental aspects of spectroscopy. Fundamental aspects of spectroscopy. What is exactly the spectroscopy means? The spectroscopy is coined in Latin and Greek as spectrum means ghost or spirit, and scopy means to see. Spectra means what? Ghost or spirit, and scopy means to observe or to see. What exactly the spectroscopy tells you about is interaction of matter with radiative energy. Interaction, suppose if it is a matter, now interaction of radiative energy with matter. That is the fundamental information which you are going to get from what? Spectroscopy. Now, what is the origin of spectroscopy? Spectroscopy was initially, in the historical definition, the dispersion of visible light upon interaction with a prism was initially the historic definition of spectroscopy, whereas in the current scenario, the definition of spectroscopy is interaction of either the frequency component or wavelength component of the matter or electromagnetic radiation with matter. What matter means, that is the sample which you are going to study. Now what exactly? Suppose now I am observing this in the presence of a light. Okay, this is an object. I am observing in the presence of light. Now, do I am observing the object? No, I am not directly observing the light, but I am observing the ghost or the degrees of freedom of interaction of matter with light. That's what I am seeing by my eye. The spectroscopy tells you the same thing. Interaction of what? Electromagnetic radiation or with matter. That's what we are seeing, the ghost part of the matter rather than the exactly observing the matter. Now what? When you are aiming at the object, you are not viewing that directly, but you are viewing the different degrees of interaction of molecules with light. This is the first thing. Now the current definition is any interaction of radiative energy as a function of wavelength or frequency. Now spectroscopy is classified into three types. First one is the classification based upon type of radiative energy. Second one is nature of interaction. Third one is based on the type of material involved. Now type of radiative energy. Radiative energy may be electromagnetic radiation. Most of the spectroscopy techniques use electromagnetic radiation as a source of their energy. And sometimes you can see particles or matter waves. Sometimes you can see the acoustics. Sometimes even it is a mechanical one. Now, nature of interaction. What is the nature of interaction? Whether the sample which you are going to visualize or analyze, whether it is observing the incident light, or whether it is emitting the incident light, or whether it is scattering the incident light, or the incident energy is in resonance with the sample. That we are going to the nature of interaction. Now, type of material. Now it may be an atom, it may be a molecule, it may be a nuclei, it may be a crystal, based upon this type of material. Suppose, now what do you understand by AAS? What is AAS? AAS means atomic. The type of materials are atoms. Nature of interaction is absorption, and total it is atomic absorption spectroscopy. Now presume single crystal XRD. It is an interaction of X-rays with sample. X-ray crystallography. Now matter is electromagnetic radiation is X-rays. Now matter is your crystal, that is called as X-ray crystallography. That is the one more technique. Now what exactly, in generally in most of the spectroscopic techniques follow what? Electromagnetic radiation. What is an electromagnetic radiation? Electromagnetic radiation is one which contains both electric nature as well as electric properties as well as magnetic properties, which are running in what? perpendicular to each other, both electric property as well as magnetic vector. It's an electric vector, other one is a magnetic vector. It's a vector quantity which has some direction. You can see the direction of motion is always in a one way, but we are moving towards right angles to each other or perpendicular in motion. Now what exactly in the electromagnetic radiation is studied in terms of its wavelength properties, or sometimes it may be in the frequency properties, but most often it is in the wavelength. Now if you see the frequency, it is on a frequency scale. Now according to the Planck's constant, E is equal to h mu, or frequency is also c by lambda, that is c is the velocity of light and wavelength is the distance between two crests or two troughs, or distance between two identical points in a wave. Now what exactly is this scale tells you about? With the increase in frequency value, there is a decrease in wavelength value. Now you can see the electromagnetic radiation. Suppose this is, if you see the visible or UV light, is divided into violet, indigo, blue, green, yellow, orange and red. Different demarcations of this visible and UV light. Now what you are observing here, there is an increase in frequency value and decrease in the wavelength value, as these are inversely proportional. Now the spectroscopy origin, when the spectroscopy originated, means it's originated from the Planck's definition of black body and Einstein's definition of photoelectric effort and Bohr's definition of spectra, that is hydrogen spectra, spectrum. What is spectrum? Based upon these information, we are studying the current day's spectroscopy. Now in the spectroscopy, the components in both you have electric and wave nature. Now there are some properties with which the differential interaction between the matter you will study what type of matter you have. Now suppose there are components of electromagnetic radiation, that is period, frequency, wavelength, amplitude and wave number. What do you understand by a period? That means the time taken for a complete cycle to pass through one point in space, that is called as period. Frequency, number of cycles per second. Suppose this is one complete cycle, number of such cycles in 1 second is gives a frequency. And wavelength, distance between two crests or distance between two troughs or distance between two identical points in a propagation of wave, that is called as wavelength. Then amplitude, that is the height of the wave, is called as amplitude. Wave number, number of waves per centimeter. In hierarchy, both wavelength and wave number are inversely proportional to each other. How you see? Wavelength means the distance traveled between two maximum points in a wave, whereas wave number, number of waves per 1 centimeter. That itself tells you that wavelength and wave number are inverse in relation, which we are going to study in the next classes. What is the difference, importance of this? Now speed of light is the multiplication of wavelength and frequency, and wavelength is equal to speed of light by frequency, and frequency is equal to c by lambda. Now same you can see, E is equal to h mu, frequency is c by lambda, E is equal to hc into 1 by lambda, E is equal to hc into mu bar. What does it mean? Energy is directly proportional to the frequency, energy is directly proportional to the velocity of light, and energy is inversely proportional to the what? Wavelength. This is the fundamental difference. Now whenever there is a propagation of light, what exactly you identify in a propagation of light? When the light is propagating, that means the kinetic energy explains you about the wavelength. That means something is moving, kinetic movement, whereas potential energy, static energy, whereas kinetic energy, energy because of motion. Now according to de Broglie's explanation of the particle waves, wavelength is inversely proportional to momentum, that is lambda is equal to h by p, and frequency is directly proportional to the energy. These are the two definitions suggested by the de Broglie's particle waves. Now what exactly P is? Momentum. Momentum means mass into velocity, and you have some Lorentz factor. Now Lorentz factor, if you multiply, again you get lambda is equal to h by mv into, this is multiplication of Lorentz factor. Now whereas frequency is equal to E by h, frequency directly proportional to energy, Now energy E is equal to mc square. From where you get Einstein's formula, E is equal to mc square. Again there is a Lorentz factor in it, mc square into again Lorentz factor. Now finally summation of both Planck's and de Broglie's equation, we will get P is equal to h into k. P is the momentum, h is reduced Planck's constant, that is h by 2 pi, that is sometimes also called as Debye's constant. Now k, momentum is directly proportional to the wave number, this is the final definition, and frequency is directly proportional to the angular momentum. This is the overall definition of introduction to the properties of light, which are going to interacting with the matter and which are going to observe the different degrees of freedom of interaction of light or incident energy with matter. In the next coming classes, we will discuss what type of absorption, whether it is emission, whether it is scattering, whether it is resonance, what type of molecules are interacting. This is only the fundamental definition of properties of light, properties of matter, and so on. Thank you.